Welcome back to our Code Along tutorial series. We have come a long way in getting our estimation application complete. Today we will see that labor pay off, where we are creating the user interface. Without any further delay, let's get into it. Before we can start creating our user interface, we need to refactor how we open our jobs. So right now we have a property on our main window.xaml.cs that is selected job, and when it changes, we will go and find that job, open it. Now that doesn't scale very well for our entire project. So what we'll want to go and do is right-click our project, add a folder. We'll call this handlers. Inside of this folder, we'll want to create a new class, and we will call this job handler. So the point of this class is to be our single source for everything related to our jobs. So we'll go ahead and we'll make it public. As it's single source, we'll want it to become a singleton object. To do that, we'll need a private static job handler instance. We'll also need a private constructor. And then we will also need a public static get instance. So what the get instance will do is when a person wants to grab an instance of our class, we will check to see if our instance is already populated. If it is, we'll return it. Otherwise, we will create a new version of it. So we'll say if instance is null, then instance is equal to new job handler. Then we'll just say return instance. Alright, so here we go. Perfect. We have our singleton set up. Now what we want to do is to create an event. So every time our selected job changes, we can fire that to notify everyone in the application who cares that the job is updated. So we'll say public event action job changed. Alright, perfect. Okay, now we need to add a couple of properties. But first, let's add a new using. Let's say using design data.sds2.database. Then we can add our property of job. So we'll say prop tab job selected job. Say enter. Now we want to set the setter to be private. This is just so that no class outside of our job handler can actually set this property. Now we need to add a property for our job identifier. So we'll go ahead and we'll add a private backing field for that. We'll say private identifier job identifier. We'll say public identifier job identifier. We'll say that the get just points to our private backing field. And then with our setter, we'll say if job identifier is equal to value, we just want to return. Otherwise, we'll say that our backing field is equal to the value. Then we will say job selected job equals job dot find job, pass in our value. We'll say selected job dot open, and then we'll say job changed. So we're doing an Elvis operator to make sure that it's not null, and then we'll just say invoke. Alright, perfect. So now we have our job handler set up. Now let's go and make sure that our job handler is functioning correctly. So let's go back to our main window.xaml.cs. Let's go to the top. Let's add new using jobs.handlers. Now we can go back down to our selected job and we get rid of these 3 lines of code. They're no longer needed, and we don't need our private, well, we'll keep our private job for right now. Then we'll say job handler dot get instance job identifier is equal to value dot job identifier. Okay, there we go. And then in our main window, underneath of all of this, we can register to our job changed event. So we'll say job handler dot get instance dot job changed plus equals, then we'll just use tab. It'll auto generate a method for us, which is perfect. And we can just delete the auto generated inside of it. We'll say cw tab, or that's just console.writeLine. And then we can go ahead and we will set a breakpoint there. So we make sure we're running in 64-bit, then we go ahead and click start. So what we are expecting is that when we change a job in our drop down, we should be able to get this breakpoint to trigger. So here we go, we drop our drop down, and there we have it. So we do see that our job changed event is working perfectly. Perfect. Now we can go back and delete these additions here because they aren't actually needed for our application. They're just used for testing. Now we want to be able to break our application up into logical chunks so that way it's easier to maintain in the long run. In order to do that, we'll need to create several different user controls. So let's go back to our jobs. Let's right click, say add new folder, and we'll call this folder controls. And inside of that controls, we will go ahead and we will say add new item. We will be looking for user control for WPF, user control WPF, and we can call this estimation. Okay, so the very first thing we want to do is make sure that we are actually adding our control to the main application correctly. So let's just go ahead and let's just add a label. We'll say that the content is equal to estimation. Then we can go back to our main window.xaml. Here we'll need to add an XML namespace. So at the very top we'll say XML namespace controls is equal to jobs controls. Perfect. And then instead of just this label being bound to this content, what we'll want to do is we can say controls estimation. This will be in grid row 1. Alright, perfect. So we can see that our estimation label is now showing up here, which that is awesome. So let's go back to our estimation.xaml. We'll want to go ahead and add a name to our grid here. So we'll say x:name is equal to grid. I'll go into why we're doing that in just a little bit. So for this grid, we're going to want to add 2 rows. So say grid.row definitions. The very first row will have a height of star, meaning to eat up the rest of the space. And then we'll have a row definition of height auto. In the first row, we'll want to put a scroll viewer. In this scroll viewer, we will have a grid. This grid will have 5 rows, all equal height. So we'll just say row definition. And then we'll just copy this and paste it 5 times. Perfect. And now we will want to add a group box. And we will give it a header of members. And then its content will be a data grid. Okay, so if you can't guess by now, we are going to be creating 5 group boxes, one for each type of material that we're estimating, so members, plates, angles, bolts, and welds. And each one of those group boxes is going to contain a data grid that will display all the information to our user. So for our data grid, we want to say that item source is equal to binding. I want to say members. Let's say user can add rows. I want to set that equal to false. I want to say that auto generate columns will also be false. The reason why we don't want to auto generate columns is because we want to have control. Some of our columns are going to be read-only, some of them are going to be editable. So for down here, work on our columns, we'll say datagrid.columns. So for our members, right, most of it's just plain text. So here we'll say a datagrid text column. We'll say that the header is equal to section size. We'll say that the binding is equal to binding. So this binding takes place of each member. So over here we know that our property is called section size. And then we'll say is read only equal to true. So we don't want the users to be modifying our section sizes. Then we'll say datagrid text column. Header will be length. The binding will be binding length. Oh, we need to set this to read only is true too. We'll have a datagrid text column. Header, this will be count. Binding, so to binding count is read only is true. And then lastly will be our cost column. Binding is equal to cost. And its read only is actually going to be false because we want users to be able to edit this. Okay, so that has our members data grid set up. So I would like for you to take this time to go ahead and do the 5 other data grids on your own, see if you can get it done, and then I will see you in just a moment. Alright, welcome back. So I've gone ahead and I've filled in the data grids. So let's go and talk about them for a little bit. So one thing that I did was I made sure I add the grid.row value to each of them. And I also added a margin of 5 pixels just to add a little bit of white space to help break it up a bit. If we look here at my plates, it's all pretty plain Jane. We just listed out text columns for all the different properties. Same thing for angles. Now bolts had a little tricky one because we had a data grid checkbox column because we have a Boolean value for the is tc. Now you could just use a text column if you prefer, but I like the aesthetic appeal of the checkbox column. And then we have our welds, also all text box columns. So if you recall, we set this grid to have a name of grid. So if we go back to our estimation.xaml.cs, we can go ahead and we can access that now. So we can say grid.dataContext is equal to this. So the reason why we're doing this is because when we have a user control, we don't want to set the user control's data context. Often in WPF, you'll create a user control where you can inject values into it. And here, even though we're not doing this currently, we don't want to hamper our ability to do that. So we'll just set the data grid. So we'll just set the grid's data context instead. We're also going to need to set up quite a few properties. For here, we're going to say private observable collection control dot, so we can get our using there, which the using we added was just the system.collections.object model. And then we will go ahead and add our using for our data model. So using jobs.models. So this would be observable collection of estimation member. We can call this members. And then we'll have our public observable collection of estimation members. There we go. So its getter will just return the backing field. And in our setter, we'll say if members equals value, we'll just return. Otherwise, members equals value. Now, one thing we'll also want to do is we need to implement I property changed. So we'll say I notify property changed, control dot, so we can get the system dot component model using added. So here it is, just system dot component model. And then we'll also need to implement it, so we can just say control dot here, implement interface. We can grab this event, put it down below the constructor. That's just what I like to do with it. And then we can say private void raise PR property changed. It takes in a string of prop, and this will be property changed Elvis operator invoke this new property changed event args prop. Okay, so now we have our notify property changed fully implemented. We can then say raise property changed, and we'll say name of members. Once again, we're just using name of operator, so that way if we ever rename our members, we also get this to update correctly. So let's go ahead, let's implement this pattern for our last remaining 4, and I'll see you in just a moment. Welcome back. As you can tell, I've implemented the rest of our properties. So you can see that we have our members, our plates, our angles, bolts, and welds. They're all basically identical to the members that we did together, just slightly different for each property. One thing we need to do is we need to go back to our main window.xaml.cs. What we need to do is take our getMaterials method and move it to our new control. So we'll cut this, then we'll go to our estimation.xaml.cs, and then we will paste it. Alright, and then we'll need to fix any missing references, so we'll just need to add a using design data.sds2.model, so you can do control dot to get to that list, or you can add it manually by typing it. And then we'll need to do the same thing for up here. Okay, so we see that our job.members is currently broken, and that is fine because we'll fix that right now. So in our class here, we'll say private job handler. We'll need to go ahead and add our using up here for that. We'll say using jobs.handlers. We'll call this job handler, and then in our constructor, we'll just say job handler is equals to job handler dot get instance. Perfect. And then we'll replace this job here with job handler dot selected job. While we're at it, we'll go ahead, we'll say job handler dot job changed plus equals get materials. Okay. So now when the job changes, our getMaterial method will be called. Let's go to the very bottom of our getMaterials method. Let's still get our console.writeLine. And here we'll say members equals new observable collection. We'll say temp members. Then we'll say plates equals new observable collection temp plates, say angles equals new observable collection temp angles, say bolts is equal to new observable collection temp bolts, and then welds is equal to new observable collection temp welds. Okay, now we can hit start. So with this test I was saying earlier, we should expect to see when we change our drop down here that all these data grids get filled in. Alright, so here we go. Looks like we have our members. That's looking really good. We have our plates. We have our angles. We have our bolts. And we have our welds. So all that's looking really good. Let's make sure we can't modify these. We can't, but we can modify the cost. Alright, so that is all looking really, really good. Now, there's a few instances, like with welds, right? This data doesn't look super snazzy and all that. So we can go ahead and tidy this up if you'd like. So if we go back to where we add our welds, here you go, grouped welds. So we can say EW dot length is equal to math dot round. Then we can say EW dot length comma 2. Now there could be several properties throughout this project that you want to do that on, but let's just double check to make sure this works. We should see that the length of that weld is nice and short now. And if you want to, you can go back through your bolts and your members to make sure that your lengths are all within a relative good looking fashion. Perfect. So depending on the size of your model, Get materials could take a long time to run. And since our application ultimately will do more than just estimation, we don't want to necessarily do estimation every single time that we change the dropdown. So the first thing we'll want to do is go back to and add a new folder called converters. And inside the converters, we're going to add a new class. So let's pick a C# class. We'll say bool to visibility. And this is going to implement the I value converter. We'll do a control dot to get the using, and we'll need to make this a public class. Then we'll do another control dot just to have it implement the interface for us automatically. So the method that we really care about is this convert method. Okay, so we'll say if value is bool, we'll just call it B for short, and we'll say return B. So this is going to be a ternary statement, so question mark. So if it's true, we're going to say visibility. We'll add our system.windows.data using .visible. If the boolean that we pass in is false, we'll say visibility.collapsed. And then as a catch-all, we'll say return visibility.visible. Right, you could have this as collapsed or visible. Doesn't really matter. Alright, so now that we have our converter created, let's go back to our estimation.xaml. Let's go ahead and let's add another row to our grid here. So we'll say row definition height equals auto. And then we'll want to change this scroll viewer. Say grid.row is equal to 1. So in this very first row here, we want to add a button. Let's give it an X name of load estimation data. We'll give it a content of get data. We'll give it a grid.row of 0. Give it a width of, let's say, 100, a height of 30, Let's horizontally align it to the center. All right. And there we go. So we have our get data button. And now we'll want to use that converter. So we'll need to add another XML namespace. So we use XML namespace converters equals to jobs. And we'll look through the list here. We get our converters. Now that we have our converters, we'll want to go underneath of our user control. So we'll say user control.resources. We'll say converters bool to visibility. We'll give it an X key of bool to visibility. All right. And then we'll go down to our scroll viewer here. We'll say visibility. I want to set this equal to a binding. I want to say show estimation data converter static resource bool to visibility. And then we will do this here too. We'll say, well, this one's pretty long, so we'll add a new line. So we'll say visibility binding show load button converter static resource bool to visibility. All right, so we have two booleans we need to add to our backing CS file. So let's go to our estimation.xaml.cs. And I'm just going to go ahead and collapse all of these, so that way everything's a little bit more readable on our end. All right, so we're going to be adding two more properties. So we'll say private bool show load button, but this is our private one. There we go. Then we'll say public bool show load button. So the getter will just be our show load button, and the setter will be if show load button equals value return. Then we say show load button equals value. Then we'll say raise property changed, name of show load button. Okay, then if we go back to our example, just make sure we spelled it correctly. I always like to just copy the property name. Looks like we're all good there. I will then copy this one, paste it a couple lines lower. It's kind of like how I cheat to go a little bit faster. We'll copy the next boolean. We'll paste it over these two. There we go. And then I will just replace those three instances and replace this one. All right, so now we have our two booleans. Now, in the very beginning, what we'll want to do is we'll say show load button is equal to true, and show estimation data is equal to false. So what we should see is that when we start our tool this next time around, we won't see any of our data grids, but we'll see our load button. Perfect, that's what we see. So our job handler changed event shows the get materials. Well, it does the get materials, but that's not exactly what we want it to do. So let's go ahead and create a new private method. Private void job changed. All right, so in job changed, we're going to want to change a third boolean that we haven't created yet. We'll do just now. That will actually allow us to click the load button. So let's go ahead and let's just copy this one and paste it for a third one. We'll say instead of show estimation, it will be can load estimation data. So what this is going to control, it's going to control our load data button if it's enabled or not. So we go back to our estimation.xaml. We'll say that our button is enabled, was binding can load estimation data. So down here in our private job changed, we'll say can load estimation data equals true. And so instead of get materials, we'll be calling job changed. And now we need to go back to our estimation.xaml. We'll create another line here. We'll say clicked. We'll just say create the new event handler for, so load estimation data underscore click. And then this. I don't like how it put it at the very bottom of the class file, so I'm just going to move mine to below job changed. So in this, I want to say get materials. Call get materials and show estimation data will equal true, and then show load button will equal false. Okay, let's run our very last test. So with this test, we're expecting when we change the drop down, the get data button will become enabled. When we click that button, we should see all of our data grids be populated. So we'll drop it down. We'll click our get data, and there we have it. We have our estimation window fully functional.
Now that our user interface is complete, our application is really coming along. In the next video, we will be exporting our estimation data to an XML Excel format. Don't forget to like, comment, and subscribe so you don't miss that update. Until then, I hope you have a wonderful rest of your day. Goodbye.